Hello, today I shall present rale-rnd. We are looking at how learners sense-make code architectures. The user wants to write good quality software, communicate well regarding their work, adapt to changing circumstances and technology, and eventually get a job as a software engineer, which will command a high pay. However, the transition between novice software engineer and professional software developer is a very difficult rite of passage. It has considerable drop-off, which has important implications of who becomes a software engineer in society. Right now, boot camps are very expensive, and so is mentoring and coaching. And the path towards professionalism is not a clear set of milestones. Moreover, this path is not malleable to student interest and ability changes. And so, we look at how to make this transition easier and reduce drop-off. Let's get into the specifics. What are the bottlenecks that are stopping learners from becoming professional developers? Well, we hypothesize that developers need to make sense of professional code before they can actually develop professional code. And we also think that reviewing professional code will be a great pedagogical exercise for developers before they get into replicating features that they're interested in building and eventually building their own applications that involve features from various different experiences that they were exposed to in the past. And so we look at specific bottlenecks towards sense-making professional code. Professional code bases are overwhelming. They contain obfuscated code with variables renamed. They contain syntax that is unfamiliar to learners who think that offset means one thing when it actually means something else, for example. A lot of code is overwhelming, even if you have visualizations. And internal variable values are not always known. In functions, learners are not always clear what to do when, and they can't keep track of changes between visuals and actual source code being executed. And these specific nitty-gritty items may actually be the reason why we see so much drop-off between course takers and actual application developers. So we look at two conceptual approaches, one of isopleth and one of a procedure that I have developed. The conceptual approach of isopleth is inspired by learning science. The essence of its approach is to turn source code into a visualizable structure for learners. Specifically, we look at visual representations of source code into a call graph of nodes, inspectability, because nodes are inspectable and their source code for the specific node becomes visible, as well as malleability. The graph of nodes can be arranged in different ways by dragging around nodes and their edges move in accordance. In addition, learners can label nodes, and those labels allow them to express what they think the nodes mean. A sense-making procedure I ideated has the conceptual approach of simply resolving all the obstacles found in Chrome Developer Tools and isopleth. However, that's not all it does. It looks at using some of the learning science and design concepts I learned in design of learning environments. Specifically, we look at visibility of system status. And this is exemplified by our procedure having learners look at isopleth, but then do deep dives into CDT when they need to have variable values or internal functional variable values visible at a particular point in time. It also incorporates goal-driven learning, self-directed learning, and norm-esque constraints. Learners must go through specific procedural steps. However, they can self-direct themselves when they decide whether to label a node or tree as skip, as opposed to labeling a node or tree by what they think is a summary level understanding of what that node or tree does. Moreover, they're selected as self-directed when they decide whether or not to do a deep dive into Chrome developer tools to understand some of the details. And that self-direction is actually a decision there that learners make. Do I have a summary level understanding of this node, or do I need to go into the step-by-step execution in order to get a summary level, architectural level understanding of this particular function or node? So I've highlighted some of the contributions that were made this quarter, but I'd like to give a little bit of a high-level perspective on these contributions. I used Isoplet and Chrome developer tools myself and profiled their obstacles. I ran a pilot study using Josh's measures, the Isoplet studies measures that is, but on novices that were using Chrome developer tools. I profiled the obstacles from both Chrome developer tools and Isoplet's user study, and I looked at how learners performed, finding that they performed approximately as well, but when I was going over the user studies, I found that these measures are actually not very good. They're not objective or easily graded in an objective fashion. And so then I went about scanning the landscape of 13 other competitor tools, and I profiled levels of understanding, summary, spec, or pseudocode level, and I ideated and design argued the sense-making procedure that I presented in the last slide. Then finally, I decided it's important for me to design objective measures for specific levels of understanding. And I did that. But I was criticized rightly that those measures are not objective, they are objective, but they're not generalizable. They're specific to the example that I was looking at. That is XKCD or some of the other examples I looked at. So I redesigned the Isoplet study, and this redesign can be used on the Isoplet or it can be used on a different intervention such as a procedure. But I redesigned the study so that it measures generalizable learning. Both the pre and post test are done without the learning tool, and the test occurs on a different example from the learning example. So I'd like to talk about some of the design arguments that went into Isoplet. Essentially, Isoplet said, advanced beginners want to become professionals, but they fail to understand source code because they run into obstacles like overwhelming amounts of code. And so if we simply add visual structure, manipulability, and multiple views into that source code, we can help a learner overcome obstacles and achieve greater architectural level understanding gains than simply reading code or other static codes provide, like Chrome developer tools. And this is Isoplet. Right here we see that the nodes are presented in a call graph, and you have a visual. You can click on nodes and get into the details of the code for that specific node, so it's not an overwhelming amount of code. And finally, we see relationships between nodes, and that's a lot easier to see through arrows than it is to see by parsing raw text code text. And finally, we see malleability and that you can drag nodes around and you can label nodes, and inspectability. Now, the design arguments for the procedure I proposed are slightly different. I agree that learners want to become professionals, but specifically they want to attain structural, functional, and occasionally even line-by-line level understanding of source code for website features so that they can eventually replicate those features and use those features in their own applications. However, learners face several obstacles that I profiled, and they are uncertain on how to start sense making. They're faced with unknown code structure, unknown variable values. These are all examples of obstacles, but overall, they lack clarity on what level of understanding to go for. And so we help learners by providing them a step-by-step procedure to track their understanding of functions, of relationships, using Isoplex, but also deep diving into Chrome developer tools as necessary. And this procedure helps learners overcome obstacles, but also track and label their understanding at the functional level, at the call graph tree level, and as needed, even at the line-by-line level. And it ensures that a learner can quickly get unstuck. That's really the design argument, is that through resolving all of these obstacles and giving a learner an option whenever they face one of these obstacles, we prevent them from getting stuck, or at least provide them a way to get unstuck. The technical approach of this procedure is that the user gets a holistic picture of the web page by looking over the entire HTML tree. They label nodes and mark them either individually or at the tree level. They can mark them as well, but they can also mark skip at an individual node level or tree level. And this notion of marking skip on a tree level is important. A learner is allowed to skip a whole bunch of code by just marking skip on the entire tree. However, they are aware that that code exists, they're aware that those function call exists, and they have achieved a holistic picture of the call graph. The obstacle of not knowing exactly what happens or what the purpose of a particular node is, even at an architectural or summary level, that obstacle is resolved by the procedure giving the learner an option to deep dive into CDT to find out what variable values are at every step of the function. And lack of knowledge about how JavaScript affects the page visuals is another obstacle we ran into, and how it affects local data. And that's resolved really by having the learner reminded frequently when they step-by-step go through code in CDT, reminding them to look at the files that are loaded after every line executed, to look at the variable values changed, and most importantly, to look at how the web page has changed after each line. And that's where we get some specific obstacles resolved. This procedure can, of course, be Wizard of Oz, but it can also be implemented in the style of a website tour, like Bootstrap website tours. It's a constrained process, but it has aspects of self-direction. Now, I also was asked to pivot a little bit and look more at measures. Think less about intervention, whether we're using Isoplex or whether we're using a specific procedure that should overcome obstacles in Isoplex and Chrome developer tools. We need a good study to measure whatever the intervention is and whether learning is occurring. So, the research question. The research question is, does Isoplex, or whatever tool or procedure we use, does that help learners achieve greater architectural or spec level understanding gains than that which they would get from simply reading source code or using status quo tools like CDT? And I propose a study that should measure learning. It essentially contains a pretest where we have a learner architect some app B, then an intervention like using Isoplex on some example A, where example A has conceptual overlap with app B, but is not the same as app B. And then has a post test where the learner just goes about architecting app B again, but keeping in mind the paradigms they were exposed to when using Isoplex on example A. Now, I, in addition, introduced some probes to measure example-specific learning, example A-specific learning, that is training example-specific learning. And these probes were called quizzes. They had objective questions about the specific example A and asked the learner to draw diagrams and also explain their answer to objective questions. Dan gave me the feedback that those probes might actually mess up the study design. Nell suggested that it might be technically okay since the experimental and control condition both have those quiz probes. However, we could even do better. We could make the experiment simple, just have a pre-test, the intervention, and then the post-test, and then use the quiz questions to elicit mechanism. We could have the post-test, a quiz on the example A where we can elicit exactly how learners made objective decisions of multiple choice question answers. We could also have in that post-test, the post-test activity. We could have them answer other interview questions to get into that mechanism. We could also track click activity and tool coverage and then ask questions to learners about why they used a certain tool this many times. And by looking into that mechanism after the post-test, we aren't actually changing our study results, where our study results are basically the difference between the post-test and the pre-test performance to measure understanding gain. But we, at the same time, we're able to get into mechanism. Now, this procedure should measure learning, but I'd like to be clear on the specific prompt and grading rubric that we would have for learners when we tell them to go about architecting app B. This is the prompt. We would actually have learners draw a call graph, not very different from isopleth. However, we would have them draw this call graph for app B and how specifically they thought app B was implemented. It would involve drawing nodes, it would involve drawing edges, it would involve marking those nodes as whether they're listeners or whether they're functions and whether they're involved in setup or mouse activity, etc. Then we would have an objective way of grading this. The algorithm for grading this divides the score into overall and detail. First, a grader would assess overall whether the entire architecture is good or not, yes or no. Specifically, whether the design choice is good given infinite resources such as memory and time, and whether the design choice is good given finite resources. So basically, whether the answer works technically and whether the example would work in practice. A grader would assess the overall application that is presented, the overall architecture that is presented, and that would account for 50% of the learner's score. Then the details would account for 50%. So each tree in the diagram that was presented would be graded, and the tree details, for each of those trees, they would get an overall score, and then they would get detailed scores. And so when you look at the trees, then individual nodes would get an overall score, and that would account for 50% of whatever that node accounted for in terms of the grade, and 50% would be grades specific to the details of that node. So we would almost have a fractal that is created by this rubric. You have an overall score that for 50%, that accounts for 50% of the score, and then details account for the rest of the 50%. And that keeps on going on until you get to the most granular level of detail. And so we cover a grade for the entire call graph, for trees within the call graph, and then also for individual nodes and for individual aspects of nodes. And every little decision that a learner makes contributes to the grade, but that contribution is scaled to how much it impacts the overall design. Now I will present an example measure. An example prompt for app B would be, you want to build a digital scrapbook of all your pictures. Architect a site like Pinterest. Note you have 10,000 pictures. Example A might be XKCD in this case. We see that XKCD, where a learner is dragging and loading new parts of the world, has overlap in concepts with this prompt for app B. The overlap is lazy loading of images, except we're dragging in XKCD versus scrolling here. Now, the outcome that we seek is that novices who could not architect applications before using Isoplex, on an example, should now be able to architect applications after using Isoplex. We run into certain limitations. We may be criticized that the pretest that we give out may put novices in the mindset of thinking about architecture. However, we need to do a pretest. Another limitation is that this study or project at all doesn't really address the fact that you could have just curated examples. Is it really better to do examples from the wild that learners choose as opposed to cleanly built canonical examples? However, our hunch is that since the web changes so fast, and also since learners have different interest levels in different types of websites, it would be better to have our software work on a good fraction of the examples out on the web as opposed to only a few canonical examples. The takeaway here is that novice developers want to become professionals, but they get stuck using CDT or Isoplex in sense making. And so we needed a procedure that resolves those obstacles, and we also needed a study design that truly measures learning, where the pre and post tests are done without the learning tool on an example different but conceptually overlapping with the training example. How does this fit into my long-term vision for Rail, and how does it fit into Hauchi and Nell and the group's overall long-term vision for Rail? Well, I envision a crowdsourced platform that curates Rail examples, and once a learner goes through enough Rail examples, they can start coding up architecture diagrams that they proposed. When they're coding up these architecture diagrams, they're essentially replicating JS application features. Repeated exposure to this rich portfolio of real professional code, concepts, and also these architecting and coding attempts should get a learner to almost professional. Then they can easily jump into a couple demo projects of building their own JavaScript applications or even other applications, and completion of those demo projects should make them a full-fledged professional, entry-level software engineer ready to charge money for their craft. Thank you.